was making the invisible visible. So we primarily looked at kind of making, well, ideating to make a portable kind of air quality monitor that anyone could take around, and it just easily kind of told them what the air was like that they were breathing. We'd made it so it would attach to the back of your phone, as just everyone's kind of got a phone. So it was just kind of picking up on something that I don't know, it's just an easy way that everyone could include that in their life. This was very much kind of like we had a form of what we envisioned that to look like. And then we'd also created a separate kind of prototype device that was literally just in like a cardboard box. It had the sensor that we've used in the project with you guys. So it did have that, just to kind of show that it was possible, but within the time frame of that module, we didn't have the opportunity to kind of take that any further. It was just a very rudimentary LCD screen with a microcontroller that just talked to the sensor and displayed the kind of the values of the PMs, VOCs that people were breathing. Yeah, so I was mainly on making that kind of prototype for that module. And then I'll let Z.
So yeah, as I was just explaining bits of it, got these slides here. I was gonna share it, and so I'll just get started straight away. So kind of already been explained by Matt and Ollie. This came from one of our modules, which is the Living Lab module. You can kind of see the photos there, a little sort of form prototype that we made that attaches to the back of the phone, and set cardboard model with the sort of the functionality of the air quality, which then sort of brought to the 4 weeks that we worked together with Steve for the indoor air quality sensor, which aims to measure the air quality in the indoor setting, and to assist the sort of improvement strategies for air quality. So dive in straight. We first looked in sort of just creating a bunch of initial ideas, trying to get a good grounds of what we want this to look like. And so we looked mainly in ways to convey the AQI to users by various methods, which you can see here, a bunch of sort of sketches that we have done with a bunch of different lights and LEDs that we thought could be useful, as well as a few sort of AI images that we just quickly chucked in to get like a quick form factor of how it could look like physically. And then actual sketches that we've made on how it would look like, and just like different processes that we went through to get a better idea of what we want, which then sort of lead to the housing design. And so with the housing, I first made a very basic box with the necessary components fitted as tightly as possible. And then sort of going with that box design initially, went then with a LED look by allowing light going through it, and with that a sort of grill design at the front facing section of the product. Went through a bunch of different patterns and tried different shapes and sizes and see how it looks. And I ended up going with this sort of controlled chaos concept by layering 2 different panels with different patterns, which sort of create like a diffusing aesthetic with it, which kind of goes with what I wanted, which is a way to diffuse glaring light, mainly from when you blast a very tiny LED in a direction, and just trying to make it so there's a big panel rather than a tiny LED. And then we'll dive a little bit more into the housing, because it also leads with the sort of hardware components. But one of the main main things that we really looked into, even back in our sort of academic module, was the sensors, because without the sensors, kind of defeats the purpose of having a air quality sensor. So we went through different types of sensors, looking at the sort of pollutant coverage that they cover, mainly PM2.5, PM10s, NOx, which is mainly NO2s, and VOCs. We also looked at the accuracy and the resolution that the sensor can sense in, as well as the response time. And for the sake of compatibility, we also looked at whether they work with Arduino and or ESP32, which will be explained a little bit later, as well as the costs in general. And then we went with the SEN55 at the top.
Thank you, Z. Okay, moving on to some more of the kind of hardware technicality parts of the device. One of the main kind of components that we were looking into is the microcontroller. So it's just kind of like the brain of the device. So our previous prototype did use an Arduino Uno, which is a very kind of rudimentary standard microcontroller that's just very easy to use as like a plug and play device. But since we'd kind of done some more ideating and looked into more of what we needed this device to do, we realized that we'd need some network connectivity. So that's when we started looking into the ESP32s and different versions of Arduino. So just different types of microcontrollers that can be used. We also knew that considering how important the data logging aspect of this project was, we needed a real-time clock or an RTC, which just has an onboard battery and is you set it at like GMT time, and even when the device is off, it will keep that time. So whenever the device is on and logging the values from the sensor, you will always be getting those kind of what's it called, incremental, the same incremental time values. And then we also we had an SD card reader for a local storage option. So this was just, as well as having the network aspect, was a way to save the data if the device isn't connected to a network, or it's not available to be able to connect to a Wi-Fi or something like that. In the top right, you can see the sensor that we ended up choosing, which was a sensor in SEN55. It was a more expensive sensor, but it did everything that we needed it to do a lot better than most of the other competition. It had a lot better compatibility with microcontrollers in terms of it came with its own kind of like libraries and that kind of thing. We made it really easy for us to use. Well, relatively easy. I don't know, we'll get more into it, but we had quite a few issues getting the sensors to work with the microcontrollers that we ended up using, just in terms of just a learning process for all of us, I think. But yes, in terms of just different hardware just doesn't like to work together sometimes, and that just makes it more difficult for us, but that's all part of the fun. And then just the LED in the bottom right, sorry, is just the that's just, it let us use multiple colors, and that was great for our AQI as we needed it to show from green to purple maroon, and it was relatively inexpensive, so it was perfect for the project. Next slide, please. Okay, so moving on to some of the hardware design process. You can see in the bottom left, this is the kind of basic way that we were working throughout the project. So it's just using breadboards. And that is just a really easy way to kind of interface with all the different components. It means you don't have to kind of solder anything in place. Nothing is permanent. So every time we're changing things when components aren't working, if we've soldered like some headers onto a component and accidentally fried a board, it makes it really easy just to switch them out and get them working. So yeah, so there was a lot of testing, getting the real-time clock to work with the SD card reader to pull the correct timings for each of the readings that it needs to do. For the sensor, we will go more into that on the software side, but in the end, we decided to take measurements every minute. And so it was crucial getting the real-time clock to work with the microcontroller and the sensor to ensure that those increments were correct. And yeah, we weren't going to have any problems there. So once we kind of worked out a lot of these problems that we've been having and done a lot of messing around with getting these components to work together, we moved over to kind of trying to make a actual PCB for the components. The reason that we're doing this is because, as you can see from the picture in the bottom left, it's just a lot of wires. The components are very messy, things can fall out. It's just, yeah, it's not a good way to have all of your electronics inside a portable housing, because things are going to fall out, all types of stuff's going to happen. So we transferred that to a schematic diagram, which you can see, and then that let us plot the PCB layout, which is on the right hand side. Sadly, don't have a picture of us CNCing the PCBs, but that is something that we're fortunate to be able to do at TEDI. So just from like a base copper plate, just have a CNC that drills the holes and makes the like various routing that you need for the board to work. It was quite difficult in terms of we had quite a few components on the board, and more often with these more complex kind of hardware designs, you'd be able to have like a multi-layered PCB where you have tracks and routes running in between the layers to each of the different components, and it basically stops when you're having tracks over, like crossing over each other, which obviously is going to short the circuit, and you can't have that. So we did have to, we did have to kind of just kind of jig around with it and using SAM wires to get around these issues, just because in the time frame that we had, we didn't have time to make a multi-layered PCB. We just had a single-layered copper board that we had to work with. But yeah, that was some of the hardware design stuff that we were looking into. Next slide, please. Looking into the software part of the device as well. So there are three main services that we used. So the main bulk of the device is coded using Microsoft Visual Studio Code. So this is done in C++. It is just the base kind of program for the ESP32 that we used. So it just governs all the logic that is going on inside of the device. It communicates with the sensor in terms of telling it when to measure the pollutants. It pulls the data from the real-time clock to make sure we know what time when we're actually taking the readings, and then helps well, doesn't help, it does the reading and writing the data to ThingSpeak, which is the next piece of software that we used, and the micro SD card. So we chose ThingSpeak because we had experience with it before. We'd used it in one of our previous modules. It's basically, it's just a kind of like a website that you can write to from the Arduino or ESP32 in our case. So every minute when we took the readings from the sensor, we just also take those readings and upload that to ThingSpeak via like their link API that they provide to us. This, which I'm sure Steve has used, and you can see in a bit of an example there, you'll see the broader dashboard in a later slide, but it just gives you a good overview of the last hour, or it lets you completely define how much like back in time you need to see the data. And you can also play around with all the different values that you're getting. And then one of the last pieces of software that we used was called Scriptable. We did want to, when we initially started this project, we thought it'd be really cool if we could have an app, something that you just go onto your phone and you can see what the quality is like around you, or you get a notification saying when a certain PM value or something is too high. But with the time constraints that we had, we settled for using Scriptable, which just let us use widgets on native iOS, on like Apple phones, and let us display some graphs and values like you can see in the bottom right. And yeah, that was a good way for us to kind of get around not using an app. And it's not the perfect way, but it was a good demonstration of how the data could be used and displayed on a phone. Next slide, please. This is just the kind of flowchart diagram of how the program works. Go through it very quickly, but it's turned on. You either set it in a network or local mode using the physical switch on the back of the device. If you set it in network mode, it starts an access point using the microcontroller. So the ESP32, in our case, kind of becomes a Wi-Fi network that you connect your phone to. You then provide the details of whichever Wi-Fi network is near to you that you want it to connect to. And then once it's confirmed those details, it can start the sensor measurement. And then that's when it goes to log the data to the SD card and also update, send the data to ThinkSpeak via the API. And the local mode is basically just, it goes straight into measuring the pollutants and logging that just to the SD card, not to the Wi-Fi. And yeah, and then so that goes down through to calculate the AQI, and that AQI, depending on the value, is displayed in the LED with the color. Next slide, please. Moving on to the AQI scale, sorry. So for the AQI scale, we used the UK guidelines for indoor air quality monitoring, as we knew from the brief that this device was meant to be for indoor spaces. So essentially, the program that we had on the device takes the pollutant concentration of all of the PM 2.5, 10. Initially, we did have it for VOCs, but we'll get to that in a sec. So all the various PM values, and it kind of mapped it to our AQI score thresholds that you can see is a little bit, maybe a bit difficult to read, but the thresholds that we've taken from the UK guidelines. And then using some kind of like interpolations, sorry, it kind of would give us the value of the AQI by taking the highest pollutant. So if PM10s were at a moderate to high range, but PM's 2.5 and 5 or whatever, when it would then try and kind of calculate that and say that even though the other ones aren't as high, even though the other ones aren't as high, PM10 is still high. So therefore, it's going to display a higher value in the AQI scale. We did a lot of messing around and kind of tinkering with this AQI scale. We did have quite a few issues with it in terms of getting them to work exactly how we wanted. The VOCs and NOx on the device, because it's kind of like an index, we don't get a singular value from the sensor. Sensor and the company who make the sensor has their own kind of proprietary index that they just basically outputs a number between it starts off between 0 and 100, and then it references on that index. And it made it really difficult to use these numbers, as we couldn't get the raw values, which was an oversight that we hadn't really anticipated as we used the device. It is good for showing that as VOCs change. It's just, it required a lot more back end from us getting it to actually work how we wanted. But in the end, we didn't put these values in the AQI just because it ended up messing up the colors. So even if, I don't know, you were in a well ventilated room, VOCs could sometimes still be really high, and that's obviously not what we need from this device. Sorry, next slide, please. Okay, moving on to some of the prototyping and testing that we did. Considering we hadn't properly used these devices, the sensors before, we did some reliability testing. So we had some other of the identical same module sensors, and we just did some multi-day tests where we set them up, connected to the internet, and then came back after a number of days and compared the data that we received. And thankfully, everything that we received from both devices looked very similar. Sorry, was very similar. So this was really good to see. And we did compare it to another off-the-shelf device as well as the AeroNet 4, which was provided from Steve. And so yeah, so this made us, it was happy to carry on using using these sensors. Thank you. Next slide.
Yeah, we then took set sensors and tested it in different areas. One picture on the left is us putting it near the road, near the bus stop. See if any of like the pollutants from just cars in general make a difference, which it did. And so just further solidifies our calibration and making sure that the sensors are working. The second picture shows one of our first few testings of the LEDs, how it would show through the golden grill design, their first prototypes, which then sort of evolved to the third picture, which is a relatively more like updated version where we tried testing it with a relatively populated shelf. And just as its own unit, it is not that disturbing from just being there. However, if you do focus onto the light, you can then see the fact that, oh, it is red. And so sort of just makes it, it doesn't disturb you as you're doing your normal day activities within the room. But then when you take notes of the fact that it is a color, then you would know, oh, the AQI level is now this, or that. And then the last picture, which I hope I can play the video of, there you go, is a test on looking at different viewing angles, because you don't necessarily have to look directly straight towards it. You can look on the side angle, maybe just walking past and you just have a quick glance and you noticed it. And so that sort of little clip shows the fact that you can still see from different angles. And yeah, that just repeats the video. Next. And this then led to the final prototype that we end up with. So I kind of ordered it wrong, but from the second picture and the third picture, you can see the sort of internals of this product. The caddy that we made ensured that the PCB and all the electronic components, especially the sensor, is kept in place and where it should be. This whole sort of caddy system then slides into the main housing, which keeps everything in place. And one of the other reasons why we have holes in our design is so that we can allow air to flow in, so that the sensor can actually sense the air quality. And yeah, and then the last picture just on the right shows it being used just in general with a yellow front grille, just a bit of design aesthetic. And jumping all the way to the left is the most recent one that Matt had worked on for quite a while now. And I also looked at different materials, because with all these prototypes, we 3D printed using our university's 3D printers. And to pursue in making it more lightweight, I looked at lightweight PLA, which is more lightweight than original PLA, which after printing also gave a very nice little texture to it, which was pretty nice. But yeah, upon reflection, kind of glad that we actually managed to get a baseline product going, especially within the tight time frame that we had, excluding the first 10 weeks of the concept building of this product. We also then learned to be able to further incorporate our skills in 3D design, PCB design, and software development in making an actual viable product. In terms of improvements, I'm thinking we could potentially make a dedicated app to be able to provide a better experience in using and accessing the air quality data, and having said data to be able to put this device in remote areas, because right now it is reliant on being connected to the Wi-Fi or just stored locally. It would be great to be able to have said local data on the SD card to be accessed via Bluetooth or Wi-Fi when the device is then reconnected to the phone or some other device. With remote censoring also come with power. So to ensure that this device can be powered without having to plug into the wall, we would want it to be battery operated, as well as allow for USB-C charging, which fortunately with my recent project, I managed to get USB-C charging working. So potentially that could be something that could be implemented. And finally, a small little toggle that I thought of to be able to cycle through specific air pollutants and their levels, because right now it is a full calculation that just sort of averages and collects all of the sort of different types of pollutants that it measures and just gives one of the highest ones and shows it as the higher one. Whereas it would be good when the user wants to know a specific air pollutant, maybe through like a button press, to be able to just cycle through different types of pollutants and then specifically tell, oh, maybe the VOCs are high or the PM2.5s are high, and X as well, something like that. And yeah, thank you very much for listening to us. Any questions?
Hi. Shall I start with a question?
Yeah.
Well, I'm going to start with a big thanks, actually, first to all of you who have been involved. I'm just pretty stunned and enormously impressed by the work that's gone through, and makes me feel proud on all sorts of levels about British universities, etc. But it's great, and thank you very much. I just wanted to go back to one of the first slides that you did about is it called the SEN 55, what that actually measures in its current form. And I didn't notice whether CO2 was one of them. So does CO2 come under one of those categories? It doesn't really, does it?
Yeah, because and this kind of comes from our academic module living lab, as well as Steve having already a CO2 sort of monitor.
Yes.
There wasn't really a need to incorporate CO2 at a time, and so we decided to just venture out into the different types of pollutants bar CO2 and see what we can measure with that, because at least with CO2 monitoring, what is currently in the market is already pretty good.
Yes.
And it didn't really add like a need for
We got familiar with CO2 monitoring as a sort of proxy for air quality, but this is actual air quality. Is that my reading?
Yeah, at least for the four main ones that we measured, these four main ones are the common ones amongst the air. PM 2.5 and PM 10 is particulate matter, so they go from dust to some other particles. I can't name it right now. NO2 is nitrogen oxide that can be formed from just burning wood, for example, or out of something else. And VOCs are volatile organic compounds that can come from like our just alcohol, car fumes, exhausts, us speaking, for example. We also got a little bit of VOC.
Right.
But yeah, that's
So,
sort of
sorry, Jake.
sorry.
No, I was
And
just going to say that we kind of the initial hope for the device was that it would be battery operated. So we were trying to keep so most of the decisions that were made were there to keep the power consumption down. So it was kind of like if we add in another sensor that also then does CO2, we are starting to, massively increase the power usage within the device. And then we kind of eventually got to the point where within the project, it just wasn't really feasible to develop a battery operated object. It's, there's a lot more concerns around how we use the battery power, how long that battery power can last, the voltage control coming off a battery as it depletes. We need a lot more kind of complexity in the circuitry. So the reason we don't have like a screen, for example, is because we were trying to keep the power down. Now that the device does run on mains power and has to be plugged in, some of the things maybe, it looks a little bit like, oh, how did that come? But that's the kind of the ethos that we started with. So that's why some of them, we haven't just also put a CO2 sensor in there. Whereas possibly now, if depending on where the project wants to go, it may be to add more things so that the device can just do more, or it might be, let's see if we can disconnect it from the mains, at which point we've got to cut down on and try and reuse as least power as possible.
No, I understand all that sort of decision making. It's just that we became sort of familiar with CO2 monitoring as a proxy. And my other question, and then I'll shut up, is about the particulate size. And we were especially interested in transmission of virus particles, and whether this device does, can get down to that sort of level really, or whether 2.5 is the smallest you can go to.
So with the sensor itself, it can go as low as PM1s. At least, PM1s is the lowest that it can go to in terms of particulate matter size. It's not a direct measurement of viruses in general, but there is a correlation that tends to come with PM1s, 2.5s, maybe even 5s, in terms of dust and virus in general. Unfortunately, the SEN55 doesn't hone in specifically on what kind of particulate matter it can be. It just measures that it exists. But if particulate matter to go up to be quite high, that tends to kind of mean that something some dusty wind went past, something happened that made the air a little bit more sort of dusty or has something in it that's not just common air. It's safe to assume, however, I do get that, virus is a little bit hard to measure. Off the top of my head, I don't know any sort of air quality sensor that can measure virus, but there probably are like a different kind of sensor that they could do it.
Not to talk over you, Z, sorry. I'm sure, I don't know, obviously you guys are all, a lot of you are trained doctors, so know a lot better about this kind of stuff than we do. But I think when we were initially looking at into the project and the sensor selection, we looked at like the size of like SARS and like the COVID particle sizes. And I think from what I can remember, albeit it is nearly a year ago, I think we were looking at around 5 to 10 microns in size. And this sensor being able to get down to 1 micron was, we thought, sufficient enough. And I don't know if I'm butchering my recollection of the sizes of particles, but that's what I remember. And
I'll jump in, Ollie. The particles themselves are much smaller, of the order of 100 nanometers or 50 nanometers. But it's seldom that you would expect to see one just floating by itself. So it tends to come in a droplet, which may be on the order that you can measure. So I think your initial research suggested there's no point trying to get down there because the commercial systems aren't there. But also they tend not to exist of their own. So you'd more be looking for droplets, which are a very close proxy for, because they are the carrier of the pipes.
Sorry, yeah, okay. Sorry for butchering my remembering of nanometers and microns. That's my bad, sorry.
Yeah. Can I jump in on a couple of points as well? I mean, the back when you were looking at this particular sensor type, the SEN55, and you did your initial trials, the indication I had, the feeling I had was this was probably a pretty good sensor and one I was quite interested in. It seemed to be responsive and doing stuff. And it did have that negative of no CO2, but I do believe that company have got the SEN66, which does include CO2. So in fact, if you like, an updated version could include an updated sensor. It is perhaps power hungry, so it won't exist very well as a battery operated device without needing permanent charging. But as a room device, it's probably quite good. The other thing about the PM values they give out, I'm not sure how much is measured and how much is algorithm, if you know what I mean, because in the end it's a light-based sensor counting specks that pass through a light source. So it's an indirect measurement rather than particles landing on a weighing scale and through a sieve and able to count them in that sort of way. So they're kind of algorithm-based measurements. And I think in the end you end up having to compromise. It would be nice to get back to the base values and then come up with one's own air quality index. But I was very interested in running the CO2 next to the other measurements, expecting that as CO2 went up, particulates might go up. But what we have found is that it seems to be very, very sensitive to VOC. So I'm going to move my screen round and you all see that? There's the device there now. Are you able to see that? Hello? Is anybody there?
Yeah.
Okay.
Just about see it.
So there we are. So there's the prototype. It's been sat there since last year. It needs a few updates before we could do trials with it. But I found my brother lives with us in this house. He comes home of a night, all the doors shut, sits down, and the display goes red very quickly, suggesting very bad air quality. Well, that's not insulting my brother at all. It's just that somehow it's picking up on, we think, VOCs. You'll note above it, there's another device, a little device I bought off Amazon that's got a screen. It's showing PM, whoops, excuse me, knocking my computer around. It's showing PM 2.5s and PM 10s, the same number. CO2 is actually on this particular device, and I can scroll between them with a little LED thing. So I'm finding that just screen color is, you're not quite sure what you're looking at times. The other thing next to it, the other device, this is a thing that was the one that originally exciting. It's called a Flow. The trouble is you have to press, it was designed for personal monitoring that you carry with you, but you have to press the little button each time. And that's simply a function of this battery life issue. So if you're going to carry it around with you, you can't be displaying light all the time. It just consumes batteries. So hence they went for this push button idea. And if you're going to display something, you end up pretty much with it needing to either be like on the Aranet, where they've got a very passive display using natural light to provide the contrast, and that consumes very, very little power, and also it updates infrequently every 5 minutes. and that means that it's not doing very much most of the time, and therefore you end up with a couple of AA batteries lasting for 6 months. If you need something very dynamic, you need power, and although it's not the same power to run a microwave, when you're thinking about little batteries, it all matters. So all of these are very, very difficult arguments when you come to design a product, and everything ends up a bit of a compromise, and you have to define what's it for and what do we need it for the purposes of somebody walking around with one. I'm not sure if that's important to us. Something sat in a room that can display is quite useful, but you need to know what that display means, and more importantly, what you're going to do with what that display is telling you. They're quite important things to know. The Aranet does that fairly well, in that it gives an indication if something's gone, gives a number, and if something's gone high. And like I say, my comment at the moment is, as I think you reflected in the presentation, when the color changes, what does it mean? What has changed to make that color changed? What do I need to do about it? And it's kind of too many variables at the moment to know what to do. So anyway, I'll shut up at that point. But I think in the end, guys, a brilliant job. You really got into producing a really good prototype in a very short length of time, which in the end does exactly what prototypes are meant to do: throw up the issues that need to be solved to really turn it into something very useful for people. And I think in the timescales, you couldn't have done any more than what you did. So a big, massive well done from me.
Yeah, definitely. I'd second that. But I think it's gone really well. One of the things, yeah, Steve. So I have, I don't know if you can see the second device. So we made 2 of these. Steve's got one, and the second one has now been built, and this is the caddy from it. Yeah, a few of the changes that we've made to it. It runs a little hot, so we've kind of introduced, opened the 3D print up a little bit just to try and cool it down, because another thing the sensor measures is temperature, and that was always slightly warmer than it should have been. But yeah, we did a lot of kind of thinking and ideating around that idea of what the light should do and what the light should show, and what the action you want from that is. And I don't know if anybody's got any particular opinions on it, but we thought about it in terms of, do you want to display all of the data to somebody, and do you want to make it very clear what all that data is? When actually, maybe we are all quite data orientated people, being from more of an engineering and a scientific background, we like to plot our own graphs and work out all of that. But actually your general user, do they care what the number is, or do they just care about what the air quality is like? And it, being oversensitive with the VOCs is hitting us there, because actually we end up warning them of something that isn't anything to warn about, and then you get fatigue from that. So we've removed the VOCs from the sensor unless it gets particularly high. But I think just displaying that, it was a purposeful decision to just also display the light as a way to kind of try and give a sense to an everyday person, like, what's going on. Right, it's red, I need to do something about this. Open windows, things like that, because it's indoor air quality. Obviously outdoor air quality is a lot harder, because what do? Unless you like leave the area. But the idea was to try and make it very simple, to just a color, that's all they needed to know about. And then if they wanted to, it does gather that data, and it uploads it online, and they could look on their phone to understand the data a bit more. But that the initial perception from a person was just, is the air quality good or bad? Do I need to do something, or is it all good? And that's where the light only kind of came from. Any other questions on the device, on the development, on what's been going on?
Is it okay if I have I filled up my quota, or am I allowed to ask another question, which is really about the two things really. One is about the size, and I think you were hoping that it might clip on the back of a mobile phone, and I wonder if that's something for the future. And the other is obviously the cost to the consumer. Whether anyone's got, can work that out at this stage. I understand it's a prototype.
Yeah, no,
yeah, Ollie,
oh,
do you
sorry,
want to
Matt,
take
you can.
No, Ollie,
I mean,
you
I
go for it.
can. Sorry, we didn't include it in this presentation, but we did go through and try to put together like a bill of materials just through like all the components and everything that we used for the device. And I think I'm not 100% sure about the actual materials itself in terms of 3D printing for like how many grams was used to make the device, especially now that the form has changed. But I think we had a end price for all the components. I believe it was about 65 to 70 pounds, with the sensor and being the kind of highest cost part of the device, and then most of the other components are just off the shelf standard kind of components that you can just use. So that did manage to bring the price down quite considerably. And in relation to kind of, I don't know, making it more portable and having it on your phone, that was, I think, something we were really interested in at the time, because it was kind of like, I don't know, we were all excited about that being a possibility. But I think after looking at the sizes of the sensors themselves, it just seemed at the moment the ones that are on the market are a bit too large and bulky. Whether that is still a way to, so I feel like the device that Steve showed did actually seem like it had quite a bit of a smaller footprint. So maybe there are alternative kind of sensors out there, or if we're making our own, people that do that like in-house, I don't know if that manages to get the footprint down considerably, but that would be a really cool possibility, I think, for the future.
Yeah, it would definitely be a downgrade on the sensor, because having a multi-polluting coverage sensor would then come with a bigger size or volume of the sensor itself. And at least with the current technology that we have so far, quite a bit of the multi-polluted coverage sensors are quite large in size. Maybe there is future, I don't know, upgrades, or maybe just a particular sensor that you're interested in would then be able to downsize to such a small form factor. But at least at this stage, it is not as feasible as we hoped. Yeah, like Ollie mentioned earlier, the idea of it being attached to the back of the phone was a fleeting dream that we hoped that it could work, not knowing the amount of sensors that is in the market and how big they are. But yeah.
Can I throw a question back to my friends and colleagues in SCCT? So having seen a device which is showing light colors or a device showing numbers, what's your thinking based on your experience of if a color changes on something, what would that mean to you? What do you think about it?
I'm a numbers person, really. I would go for numbers, to be honest. I mean, I think you've done a fantastic job to sort of simplify it, but I think people now, you might be underestimating sort of, far away from being conversant with the technology involved in any of this stuff. But so on the ARNet 4, you get the numbers, and I think that was an advance for me, really, to be honest.
Okay, but this device is linked to an app, even if it's a simplified app. Now, unfortunately, my one's not working great at the moment, so it's not. I couldn't get the full scriptable thing to work properly, and it ain't working very well in terms of the time base on it. So I don't know when it last gave an output. So I don't know that. So there's some technical issues with it, but nonetheless, I can open a little app up on my phone that would tell me the air quality that could be coming directly from the device. Would that be okay?
Sorry, I missed the beginning of that. So you're saying to translate those again into just coloured lights again?
I'll hold my phone up. You
Right.
may or may not be able to see it. I don't know.
Can't see anything.
No, it's not. It's reflecting off the screen.
Yeah.
Behind
The
there
screenshot,
somewhere is a
yeah,
number.
yeah.
Behind
So
there somewhere is a number.
the screenshot that's being shared on the screen there shows 6
Yeah.
little boxes on a phone, and each one of those correlates to a one of the measurements. So it'd be a PM1, a PM4, maybe temperature or something like that. And that's so rather than developing our own app completely from scratch, which was just not able to happen in the time, you can have these the widgets. So it works on an iPhone at the minute, but widgets on the background of your phone, so you can flick to that page on your phone and it will tell you the exact number. So the device itself only indicates a color, and if you wanted further information, you can go and look on your phone and find that information. So we were trying to give kind of the option there for people who are more numbers orientated, but the device itself was a very simple, approachable device, but the facts and figures were out there should you want them.
So does that answer your feel, Tom, or not?
Yeah. I mean, my phone's actually stuffed full of this sort of stuff, isn't it? Like how the solar panels are doing and how the car's charging and all that sort of stuff, So I'm quite familiar with those things rather than a light flashing at me, which I might get anxious about or something. So I'd like to look in more detail. I think those 6 little panels fit the bill really well.
Yeah, and I think what I was trying to say is that's not just necessarily a screenshot. The thing has worked, although not entirely as shown there, but it has worked for me. It's just obviously I'm not completely au fait in getting the thing working as it should. So that's why I want to go back down and talk to Matt and sort it a bit better. Actually, get more of a handle on the data for myself.
I think it depends who's used, who it's for really, which I'm trying to get my head around. So I mean, for example, I think there's probably a big issue with asthma and the sorts of pollutants that might trigger asthma in a child or whatever. And so you could you could see this being useful for a family with an asthmatic child, and the sort of triggers that might that might set off an asthma attack. I'm just thinking about the sort of work that the Children's Hospital, you were involved, Steve, I think, with some work the Children's Hospital were doing around some of this, and whether that sort of approach can be developed, because I those numbers for me would be what I would look at rather than a color. But it may be that for children it might be easier for it to be colors.
I mean, it does sound like a bit of tuning to an individual user, doesn't it?
Yeah.
Some might want PM, some might want CO2, some might want other things as a crude measure rather than trying to average everything out and come up with the worst one. Like the worst one at the moment on this device is VOCs, but it's irrelevant because it's like, well, the air quality is fine, and what the VOCs are just down to a person being nearby. So
Yeah.
that's useless in itself, but that's just a function of getting to learn how the sensor operates, which is part of R&D. This is all part of the process. So it's all part of the criticism that's needed to move the device forward.
Yeah, and we did speak to some people. Sorry, Steve, I can't remember their names now, from the Children's Hospital in Sheffield a little while ago. And one of the things that we were possibly interested in taking this in is, can we measure things like mold spores, and can we try and see whether this device would be able to be a proxy for the identification of mold within a space, and we could link that to kind of social housing and things like that to be able to prove the negative effects on people's health that is having within kind of mold spores being on walls and things like that from poor ventilation within rooms. So that could be a really interesting route that this project could take in the future.
Yeah, I'd agree. I mean, you've got humidity in there, haven't you? Humidity, mold spores come together. No ventilation would be spiking in CO2. So there's a whole list of readily available measurements that no one has correlated to go, these things work together. These should be the limits.
I think that's one of the things as well. Just in terms of, we discussed that, like, just seeing a light sometimes and not knowing what to do can just create more anxiety than it does help things. So I think when we talked about an app previously, when we thought that we might have more time, just in terms of, I don't know, before we started this project, I won't lie, I hadn't heard of PMs, like the PM scale, and that kind of thing. So I think a big part is then how it could be used to educate potential groups of people as well. And if there is a way that a device like this could be incorporated into, I don't know, if people can actually understand what they need to do when a certain color is showing or a value is coming up on the screen, if they get a kind of prompt or whatever it is, if there's like a handbook or whatever, I think could be beneficial, just in terms of the information gap of people, what they're breathing in, just not knowing what is actually around them. But it is then just a question of how do we do that, and how is that something that you convey to a larger audience?
In the end, it comes down to trials, and you know, some having a device you've got some confidence in, and then trialing that device. And we're at the stage of still needing to improve it a bit to be able to put it out in order to do the trials. And, you know, best will in the world, it's not top of everyone's list of jobs at the moment, including Mr. Retired Me. So it takes the time it takes. But I'm hoping to get together with Matt on the next stage, get my learning up. And I think the only way I can do that is face to face, so coming down to London and take it from there, really, because my plans for the year were really to put it out into a working environment and be collecting data from the, well, you see there's two devices. There's the TEDI device and the other one that looks reasonable. Collect that data over time and in an environment, community environment, and see what it says, see what they say, and get what people's feedback is. So
So perhaps you should do that, Steve, if you find the time. And then I still need to talk to the Darnall Wellbeing staff about whether Darnall Wellbeing might be a place where, you know, we can trial it.
Absolutely. I mean, I've been looking at Fir Vale, the community centre there.
Fir Vale, yeah.
They had a long COVID thing that
Yep.
Carrie was running, and a bit of interest there. So there's plenty of places we could go and do stuff, but it starts with having a device that we're confident in.
Yeah.
Tom?
Brilliant. I have to go.
Yeah,
I've
me.
grandchildren
Yeah.
to pick up, so I just want to echo what Tom and Steve have said about your work, and it's great work, really, really interesting, and pushes the sort of, you know, this whole field, I think, I hope, along to try. You know, you'd have thought after COVID there'd be so much stuff going on around the quality of the air we breathe indoors and outdoors, and doesn't seem to have happened. Everybody's heaved a sigh of relief that COVID is over and got on with other things as they do. But I think we do need to, you know, build on the work you've done, and it's brilliant stuff. So thank you very much.
Can I just say one final thing as well? I've got to go as well, but the old codgers who got together, Jack and myself and other, you know, sort of retired people, got together over COVID and tried to sort of do a job that we thought the government wasn't doing. Part of it was we were lucky enough to still have really good contacts within the medical school here at Sheffield. So we were actually paid to have a whole stream of medical students with us. And it's that money that we are now recycling into projects like for you, Xian, and Ollie, and Sam, and Matt. So I feel there's a sort of certain circularity in this, and I've been really thrilled with the things that you know, I've learned today. So thank you very much. Brilliant.
Thank you guys for giving us the opportunity as well. Sorry, before saying that as well. It's
Thanks
been
for having us.
very interested in carrying on product development and seeing what that's like. So yeah, it was really cool. Thank you.
Could I just say, because I didn't get to, sorry, before Ollie and Z joined at the beginning, I don't think, because we were recording that kind of for our own website and whatever, but I just wanted to check with you guys, are you all right if I did get this put onto we've got a YouTube channel and website just to show something we've been supporting?
Yeah, I'm fine with that.
Okay, thank you. And also,
Yeah,
if one of you could send me the slides that you've shared with us, that'd be really good, because we could just put them on the website as well. Thank you.
Yes, we can do that. Thank you.
Okay, guys, and from me, a massive thanks to you all, and to Matt and Sam for carrying on with the interest in this. I really do appreciate that. And Matt, I'll be in touch about coming down at some time in the next month, if that's okay.
Yeah, that sounds perfect. Yeah. Yeah, I've just redesigned the case this morning and got it all working. So yeah, I'm going to take it home and do some home testing for a little bit, and then yeah, it'd be great to
let us know when you think it's ready to go, and I'll pop down.
Yeah, sounds amazing. Yeah, thank you very much, Ollie and Z. It's been a pleasure to run this project.
Yeah,
thank you very much for the funding to allow us to do it.
Yeah. Okay, thank you very much, everyone.